Hey guys, in this example, we're going to prove a little fact about tangent lines when they intersect at a common endpoint here. So it says that YZ and XZ are tangents to circle T, and we want to find the relationship between them. Well, we can do that, and we're going to prove it by first talking about the radii. What would you say about the radius TX compared to the radius TY? Well, since they're both a radius, I would say they're both congruent to each other. Pew, 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 pew. Cool. And we know that because ZX and ZY are tangents that intersect the radius is there, I know I'm going to have a couple 90-degree angles right here and right here at Y. So I've got those two 90-degree angles. Now let's talk about a segment that's not even drawn there. Let's draw segment TZ. So we just drew TZ. And now you can see it made two different triangles. So that triangle ZXT and triangle ZYT. And then I could say that TZ, that segment TZ is congruent to itself. Thanks to the reflexive property. So we have our triangle ZXT. And then below that, we have triangle ZYT. And they're both right triangles. And I could say that they are congruent to one another. And I would use the hypotenuse leg theorem that we learned many, many months ago. And since those two triangles are congruent to each other, I know that their parts are going to be congruent to each other. So I could say that segment ZY is congruent to segment ZX by our CPCTC, which says corresponding parts of congruent triangles are congruent. So I know that this segment is congruent to this segment. So that's that third theorem that was on our notes about tangent lines. If two tangent lines like ZX and ZY meet up at a common point, then those two tangents must be congruent to each other. So let's sum it all up. Two tangents that intersect or meet at a common endpoint are congruent. So in this case, it was ZX and ZY both met up at point Z, so therefore they are congruent to each other. Awesome. So in this next part, we're going to apply that. So this says that, hey, TX, you're 12, and TZ, where's TZ? TZ, right here, you're 20. So we're supposed to find that missing side XZ, and that's, you know, because XZ and ZY are congruent, you know they're going to be the same number. All right? So check out what we got going on for us. According to the first theorem that we learned in our notes, the tangent line ZX and a radius like TX are going to form a 90-degree angle. All right, so what we see is this right triangle right here. And first thing I think of when I see a right triangle is a squared plus b squared equals c squared, right? You should be like sick of that by now. We do it all the time. And remember that A and B are the legs of the triangle, so A could be X and B could be 12, and C's got to be the 20 because it's across from the right angle. It's the longest side of the right triangle. So to find missing side XZ, I've got to use Pythagorean theorem, but make sure that the 20 is your C, and then it doesn't matter what A and B are. They're interchangeable. All right, so let's simplify that. Say x squared plus 12 squared is 144, and 20 squared is, oh, oops, not 200, it's 400. Then we could subtract the 144 and say that x squared is equal to 256. And then we could, how do we undo a square? We square root. So x equals, and the square root of 256, I think it's 16. So if xz, segment xz has a length of 16 units, then guess what? Segment zy also has a length of 16 units because they're tangents and they meet up at a common point. So cool, I hope you learned something. Tangents that meet up at a common point are congruent to each other, and we can use Pythagorean theorem because of that wonderful right angle that's formed by a tangent line and a radius. Yeah.